Hello. Hope everybody's having a good Sunday. Welcome to the stream. I wanted to share with all of you a bit about my setup because in the last couple of weeks it's been let's say a little rocky. I had problems with microphone, and I just looked at the levels, and it's actually recording. um, so we're good on that. But I did some work to readjust things, and hopefully you'll notice a few things different. First of all, my voice may sound slightly different. I've repositioned the microphone so that it's actually right next to the camera. So I'm looking at the camera right now, and right here is the microphone. And this should make it so that I don't have to mess with the boom that I had attached to the side of my desk over here on the right side. And also with some of the other changes I had made with my setup, there was an issue with USB ports, and that's why on the two previous streams, I think two in a row, I didn't have the microphone connected correctly, and I had to pause what I was doing and attach it to the right laptop, and so we had some silence on the beginning of streams. That should not happen again, and I'm going to share. You'll get a little bit of the mess of my room too, but I'll share here in a second the what my new setup looks like. So let's switch over, and then we can start coding, because we have a lot to do today on scans. We got pretty far into it, but it's kind of complicated, so I want to get to that. But first, here, have a look at. Oops, there we go. This is what my desk looks like, kind of from above. You can see the microphone over here to the right. I finally got a ring light put up. It's a little bit janky. I've got a boom arm that I used for the microphone previously holding it up. I'm not really pleased with that, but it'll work for now. And here's what it looks like from the other side. So you can see. I've got the new monitor, and it's got USB ports on the back, which I've been using, but it only had two, so I had to choose between having one thing or another on it, and that was not great. So I got a little USB hub, and it's kind of tied into the shelf, and you can see this shelf is one of the new things. I previously had the Logitech camera, just kind of using its own stand to mount onto the monitor, but then having this shelf to mount things to made it quite a bit better. For the microphone doesn't have to move, the camera doesn't have to move. It's really stable attached there to the VESA mount. And here's what we look like with the ring light on and our code ready to go in OBS over there on the right. I thought you all might just enjoy to see a little bit of what my setup looks like at home. But we should get started. So please do jump in if you're in the chat. Let me know. Say hi, and we're gonna get going on this. So what I want to do, since it's been a week, I want to revisit what we were doing here. Because I think it's going to be interesting to make sure that we get this right. Okay, so our strategy was we have this scanner thing. It's a basically an iterator. We want to iterate over the entire database, right? What we do, we don't need that. What we do is we have, a copy of the nursery data. We have iterators for each of the levels. And to create this scanner, what we're going to do is create a unique ID, which we just use system time now, and subtract the epoch, and then we get nanos, and that's a big number that should be relatively unique. I skipped going with a UUID crate. We can maybe fix that later. And then the next step is to create scanners for each of the levels, and we clone out the nursery data and put that in there. So if we can't create scanners for each of the levels, then we shouldn't be able to scan the database, right? So there's sort of a layering here. Now we have not implemented iterator for scanner, and part of that is that I wanted to implement the iterator for levels, for the level scanners, so that we could understand the sort of hierarchy. Now, in previous sessions, we've talked about the different files that are in each level of HanoiDB, and they are they start with A. That's the first one written to, and then you get B, and then you get potentially C. And you also have a file which is being merged into, which will be promoted to the next level. This is, you can have any number of these in each level, but there's at most 4. When you have an A and a B, you start merging into what's called the X file, which is the one to be promoted. So, so when we're going to scan the database, we should ignore the merge file because that's going to be promoted eventually. But we want to be able to read from any of the other files that are in this level. And we want to be able to do things like, I don't know, generate new data while we're iterating that could be inserted into the database. A good example might be you have some structured values in the database. You want to pull them out, parse them, and generate a secondary index. So what you might want to do is take that data and then insert back into the database some special keys that have a particular structure you're expecting, which represent this is the value for the secondary index, and then maybe like the key also contains the identifier for the other thing, and then any other derived value. So maybe you take a snapshot of the contents or something like that. But then that lets you do things at a higher level. Remember, HanoiDB is just an ordered key value store. But you would be able to do things at a higher level, like do secondary indexes that you can scan separately. So that might be something that someone would want to do, which means that we need to make sure that those files don't change out from underneath us. Now we're lucky in that, with the exception of the nursery data, which should be, no more than 512 keys. With the exception of the nursery data, we do have a guarantee that the contents of a file is immutable. Now, whether that file exists or not is not immutable. So we need to make sure that for the duration of the scan of the database, that file exists. The way we do that is we do hard linking. So we're going to go down here to the level scanner, and you'll see that it's going to look at the tree files, so the names of the files that are in this level, and it's going to create a new file, name based on adding an extension, which is we're doing a scan, and this is the identifier of this scanner. So the instance of this scan, and then it'll hard link that file so that even if, say, like a merge process happens and it gets promoted and removed, then we can still scan the original. And then we're collecting all of the trees to be able to read from them. So, okay. So this is where we are, and we started implementing the hard part, which is iterating through multiple tree files at the same time. We did a big plan here, talking about the different, I don't know that it's complete, but it's some of the edge cases that we'll have to handle, some of the default cases, and some of the behaviors that we need. So I'm not going to go through all of this again. We went pretty deep last time, but what we can look at is the code that we actually wrote for this. So this first bit was we need to see which are the keys at the heads of each iterator. Now we made these peekable, right? So we can call peek on it. But we're going to iterate through all of these trees that we have, these tree entry iterators that we have. And then we're going to peek and get the key out of each one. And we use enumerate as well, so that we can get indexes on those. And then once we have that, we might be able to inline this, by the way, like remove the collect and the iter, and we just do min by, but we'll see. Anyway, so now that we have this, we know that we're going to get an index into the original set of trees, and what the key is at the head of that iterator. So then we pick the minimum, because we always want to go in order. We want to pick the minimum key. And so if we the problem with this is, note that when we do peek.map, this can return none, right, as a potential result. So maybe what we need to do is handle that none, right? So when we're doing min, we know that there's a potential for none in here, and if none exists, that means that we just should ignore that particular thing as far as determining what the minimum value is. So obviously none and none are equal. If there's some, we want to treat none as that's the greatest possible value, right? So if there is a sum, then it's going to be less than the none, and the converse is true too. So it's going to be greater if none is on the left. Otherwise, we defer to the implementation of partial ordering on option. So this kind of goes around the fact that it's already implemented for option if the contained type implements it, but we didn't want to have none be the smallest value. We wanted it to be the largest value. So so in this case, we're deferring to that. So when they are both values are sum, it'll use the ordering of the internal value. So we can fall back to that. Okay. So now, once we have the minimum, this will return option of something, right? And if there is no minimum, then that means there's no trees to scan, and we should not have that situation. Note that up here we also look at if trees are empty, return none. This is a possibility that you have an empty level. You have, like, say 10 and there's 12, and you completely merged out of 11 into 12. That is possible. So I think it's reasonable to panic here. Okay, and then what we're going to try to do is we're going to try to take that next value out of the iterator. So so that the iterator that contains the smallest key, right? So we're going to take from that, and if there's none, if it's none, that just means that all of these iterators are exhausted. We may do an optimization later where we like drop iterators that are empty. So we'll have to figure that out. Okay, so this just means like there's nothing else to do here. The minimum is none, which means all of the iterators have been exhausted, and so there's nothing more to iterate on this. Now, if it does have something, then it's either going to be a key value or a deleted. And we know this because we're not iterating over posit entries. Those are handled by the tree iterator, which only iterates over leaf entries. So we have another unreachable here, another panic, which says this tree iterator emitted an internal node. We don't want to do that. So that indicates a bug in our code. That's fine to have panic. I think that like in my journey in learning Rust, there's a lot of nuance in deciding whether you return a result or whether you panic. And I think that I've come down on the side of, with help from some of my former coworkers, that you should panic when there's a bug in your code. When the answer is, I don't know what to do because this is just wrong. And this is almost like the Erlang philosophy in a way. Like, if you don't know how to handle this, you should crash. Except that it's a bit more subtle. In that when you hit this, you are terminating the entire program, or an entire thread potentially, depending on how you have panic handling set up. You should not continue because there's something desperately wrong. So okay, going back to our match statement here. If we get a key value entry, that is the thing that we want to return. So that's our next thing in this level iterator. If it is a tombstone, then we know that this is the smallest index. So we want, and this is the part we didn't finish last time, we want to loop through the rest of the iterators, and if their key is equal, if the key at the head, right, so we could loop through this, potentially. Because we've already collected it, right? We could loop through that, or we could loop through the trees as they are. But we want to make sure that the things at the first of this list, you'll note that when we construct this, so if we go in tree files, we're doing it in reverse order. So C is the newest file, B, and then A. A is the oldest file. So we're doing that in reverse order so that we can get them over here in the correct order that we want to get. Okay. So we need to, now that we have this key, we need to loop through the rest of the iterators. So let's just spitball this, and then we'll figure out a better way potentially. And we don't need that. Okay. And there's probably going to be some overlap because we need to do this as well. But yeah, if this key was deleted, then we need to consume that as well as any other keys that may shadow, and then go to the next key. That's why there's a continue here, because a deleted is not really an entry. It's a marker that this thing was removed. So we don't want to count that as one step in the iteration. Okay, I think I've talked enough. Let's do some code. Okay, so we're going to go through, I think we're going to go through trees. We're going to say for, I don't have a good name for it. So for file in self.trees, and this is smallest key index plus 1 to self.trees.len, right? Because we don't want to go beyond that. And we need to borrow mute, or we could do iter mute. Yeah, let's do it like that. I think that's clearer. So this is going to be, yeah, mute peekable, which is what we want. Then we'll do something really simple. We'll go if file.next map, and this is an entry key, right? Some key. We don't want to do next. We want to do peak, right? And what do we got here? Yeah, so we need to borrow that. Okay, what's wrong with that? Oh, we have an overlapping borrow. And I think it's this. So let's see. Let's do let entry that. The other option is that we could do let's do index. Let's do that. And we're going to do okay, that's yeah, because like I think it was a combination of immutable borrow and mutable borrow there that was making this a little weird. Let's see if we can inline that variable and still okay. Yeah. Okay, so if this key is the same, then we need to do index.next, and we'll just drop it. Truss trees. There's probably a more efficient or cleaner way to do this, but this seems to be a really simple way. So just to explain it again, we have, let's say we have all three files. We have C, B, and A. And we've determined that C has the smallest key in it. And then if that key is deleted, then we need to make sure that A and B, well, B and A actually in that order, that is not the key at the head of those iterators. So we're going to loop through from the index that we just picked through the end of the through the set of trees. And we're going to say, is that key at the head of it the same key? If it is, then we're going to pop it off and discard it. We're going to pop off that entry. Okay. Now, one way we could do this is loop through this. Because otherwise we're doing this peak multiple times. me think about that. Okay, we could do, let's try to reformulate it in terms of that. We could do keys and indexes. Whew. I keep hitting that that key on my keyboard that like pops up the emoji. Okay, so keys and indexes, iter. We're gonna skip, right? Okay, that means that we are let's do other key. Right, that's maybe a little bit cleaner. So we're skipping everything up to and including the one that we just took from, right? Okay, other key. Well, this is, no, this is not the last place. Let's just do star there and star there. Okay, so now there's a question. Cannot borrow self. Yeah, okay, this is interesting because I would think that this mutable bit is dropped already. Because we did a collect. Okay, so it's this borrow probably. So what we could do is go clone. All right, I think we're gonna back this out. Maybe we'll do the less. Yeah. We'll do the less sexy version, I guess. We need a semicolon there. Okay, so I don't really like that, but I think that without trying to figure out why the borrow here persists, yeah, there's some borrow checker issue there. Okay, so now we need to do something similar. So if we get, so that handles that handles for if it's deleted. But I think that we could do, excuse me. And this is where we can take advantage of combining these two things, potentially. How do I combine these? Because we need to do this regardless of whether it's deleted or whether it's just a regular entry. So, okay. So let's let's do this, and then we can combine these clauses a bit. So bear with me. We're going to do if entry is deleted or entry dot is key value. Okay, so here then we can do if entry dot is deleted, then we continue. Else we know it's a key value. But up here we need to do let key entry dot key. And I'm guessing then we don't need that borrow because we're not extracting it. Okay, so here we need the result of this to be you know, I'm going to restructure this. We're still going to need that continue. We're going to go if let entry key value is entry, then we're going to turn key in value. This is basically what we were doing before. Else we're going to continue because we this is key was deleted. Okay. So we combine those, and then we don't have that loop in two places. Really, this is just consume the iterators. Okay. That feels pretty good. I really wish we could have reused this because we bothered to go through all of them and peek and map and do that key thing again, and that's partly why I wanted to do it. But there's borrowing issues, and I don't know how to make that happen. So okay, so I think this would be good to see if we can test somehow. This is complicated enough. I mean, it actually, you know, there's a lot of comments in here, but it feels complicated enough that we should have a test for it. Let's think about that. So we could do some low level, like write some files. That seems like a reasonable thing to do. Okay, I do have it there. Okay. Okay, so let's write a test. Level iterate, level scanner. I'm not feeling creative on that. And let's use superstar. And we're gonna have to use create because this doesn't have writer. So we're gonna have to write some files, and we're gonna use temp file tempter. Okay. Okay. So let's write we're gonna have to use level as well. right, so we're gonna write the files, and then we will open a level, and then we'll open a scanner on it. Okay, so let's do. The neat thing about this is let's do that. And that returns a result. We'll do unwrap there. Mute, just to be sure. And let's do a B file, right? And let's do a C file. And we're gonna do some overlap. So I think what we want to do is, let's just outline a plan. Let's say A has key 1 and 2 in it, and B has key 2 and 3, and C has key 1 and 3. And so the outcome that we would expect is C1, right? B2 and C3. And maybe what we do is we write 4 to A, and so we'll do A4. And just for giggles, let's do B5. So these don't necessarily have the same number of keys in them. It's fine. And so this is what we expect out of the iteration. Yeah, let's put this up above. Okay, so we're going to write to A. I almost did Elixir there. Tried to type do. Okay, so we're gonna we should also have a tombstone somewhere in here. Maybe 6 is a tombstone. Does that make sense? Then we still wouldn't get any entry for that, but maybe these have versions of it and that's deleted. I think that's pretty good. We might want to, in a minute, scroll up to the other cases and make sure that we're covering those. Now, I just thought of something, which is interesting. This level scanner is not going to be able to return entries like so. It's going to have to return tombstones as well. So we should change this to entry. Now this actually makes this simpler. Yeah, this has to return entry. For a minute there I thought this would be fine. But what we need to do is just return entry. What's wrong there? This loop actually never loops. Yeah, that's the interesting thing now. Because we don't continue, we don't need the loop. That's kind of cool, actually. And we don't need the return here because we don't loop, so it's just some result. We could potentially even simplify this. We'll see. Okay. So we need let's proceed. We definitely need this to be an entry and not, because we need to know if a younger generation, like a younger level, has a tombstone that should shadow not just the files in that same level, but also across all levels that are older than it. So that's one thing that we need to handle. That's interesting. I hadn't thought of until now. Okay, so we're gonna add entry key val, and the key is going to be format value, and this is actually key. Let's rename it key 2 bytes as bytes. We don't want a string. Can we do that? Nah. In 2 bytes? Yeah, it's in 2 bytes. That's what I wanted. Okay, and then the value is going to be just a, why don't we do format a key dot in 2 bytes. Okay, and timestamp is none. We're going to unwrap. Always panic in your tests. Okay, so we have for A. Now let's copy this and do it for B. And we're going to do 2, 3, 5, 6. And this is B. And we're going to write to the B file. Okay. And we can do a file dot close. Okay. And we can do B file dot close. Unwrap. Okay, and now for the C file, we need to write 1 and 3 and 6 is a tombstone. So why don't I just enumerate those? There's only 3. Okay, we're going to do C file, and the key is going to be, I'm sorry, 1, 3, and 6. So 1, and this is C, and 6 is a tombstone. 3, okay, and then we're going to do deleted. And this is 6, and there's no value. C3. And this is C1. And honestly, we don't need these formats. We probably just need since we're not interpolating a key in there. We might need 2 owned. Let's see. Yeah. For static stir. So, all right. Let's just copy that in there everywhere. Kind of dumb, but here we go. And then we can do C file, close, unwrap. Okay, so we've built this. Kind of a pain to build it, but it's a small test. Okay, so now we're going to do, we're going to level new, and we pass dir. The level is 10, and compression is default. Okay, and that returns a result of self. So we're going to unwrap that. Okay, and now we can create a level scanner from that, right? So let's just pick an ID. That'll be, I don't know. Let's make sure it's a U128. Okay, so now we're gonna do level scanner, new, and we pass it level and ID, and that we need to unwrap again. Okay. So now what I want to do is basically this. I think what we're gonna do, and let me copy this down here so I can construct it. I want to do assert EQ. The other thing here is this needs to be C6 is a tombstone, because we're returning entries, right? We're not returning key value pairs. The user interface, the public interface will be key value pairs, but the internal has to track entries. Okay, so let's do scanner dot collect, and let's do a vec, and we're going to enumerate all of these. It's going to be a pain in the butt, but key value. So we're going to get C1, and actually this is right here, right? And we're expecting B2, which we'll copy here. And this is 2. And B2. I'm just gonna leave those formats. I can't be arsed right now. Okay, and then we're gonna get C3. So here's that entry. And we're going to get A4. And Rust Analyzer is mad. That's fun. Okay, A4 and B5. And let me copy this here. Make sure it's up here at the top. Okay. And I'm going to copy this one since it has B in it. And we'll just do 5. B5. And then finally we have the tombstone from C. I think this is pretty good. It exercises a lot. See, scanner. It implements iterator. Is the issue type annotation? It needs a turbofish entry. Can you auto fix that for me? Here, let's do inline. Oh no. Useless format. Okay, thank you. Let's just use the code assist because and I used, you know, this is a problem. I used toOwned instead of toString, yada yada. Okay, this variable is not meant to be mutable. Okay, because it's just going to be consumed. And we're dropping it after this point. Okay. Right, collect consumes, so it doesn't need to be mutable. Okay, let's run this test. Let's see if my editor will let me run it. Okay, so we've got a problem here. Oh, it's complaining about this test. We already had some tests. We implemented this scan. Okay. Okay, let's just run cargo test here. I think that's best. Okay, so that passed. That's good. So we are iterating correctly. Yeah, of course that one, we haven't implemented everything for that yet. Okay, so I feel pretty confident about the level scanner. Let's pop up another layer and do the whole database scanner. So remember, this one operates on entries internally, but is going to return key value pairs because that's what the public API is, right? We don't want to return tombstones. We don't want that internal implementation detail to escape. We're providing a different interface than the implementation exposes. Okay. So so now we've got we have an issue here, and I think I alluded to it last time, which is that the nursery data is just a B-tree map, right? But what I kind of want is an iterator. Yeah, fine, relaunch. I want an iterator over that data rather than B-tree map. Right, I kind of want this. But note it has maybe I want this. This is owned. Yeah, okay, so let's I think we want to restructure this. Let's look at that type signature of the into iterator. The type of the key and the type of the value and the allocator. Okay, I'm gonna spitball this type signature because what what I'll do here is I will do into iter dot peekable. That's what we want. And it's going to complain about the type, but there's the type that we want. This is what we want. And oh, that did not work. Okay, so we're going to have peekable, and it's going to be and the values are going to be vec of u8 and create nursery value. And then we need another turbo thing there. Right, okay, because this is actually what we want. I think the first pass I was like, well, we need to clone this collection, right? And we do, because we want a snapshot of it. If we don't clone it, then it could change out from underneath us. So we need to clone it, and then. But what we really want is something that gives a similar interface to this level scanner. Now we may want to. It's interesting. We may want to go back into the nursery and make its contents be, rather than this separate value object, use an entry. But that might be a refactor we can do at a later time. Yeah, let's not bother with that. I want to cut this down a little bit. Let's do here. Let's deal with this one first. Value is fine to import, and then I want to use standard collections B-tree map, the module, and then this can be shortened a little bit. Okay. All right, so little correction there. Okay, we're going to do something similar to what we did in the level scanner here. We have a bunch of iterators that we need to look at. So it's not going to be exactly the same because the contents of this are, you know, different than the entries here. But let's see what we did down here. Okay, we're not going to have this issue because we're going to have a scanner for every level, and we'll always have a nursery, even if that nursery has nothing in it. Okay, so we need to figure out how to get something similar to that, you know, keys and indexes thing. And actually this needs to be peekable level scanner. Here, we're going to do map here. Okay, that'll satisfy. Because we want all of these to be peekable iterators, right? Yep. Okay, and we're still consistent. It's just complaining we've never used this stuff. Fair. Okay, so now here we basically have, we need to get the nursery iterator and the level iterator to kind of have the same thing. So we need to construct that keys and indexes bit or something similar to it. Let's just do next. Let's just do it dumb. Always start dumb. Do the thing that makes sense, and then see if you can make it look better. So we're gonna look at self.nursery peak. Okay. And then we're going to do we'll do something similar to keys and indexes. And I think that we'll copy this and we'll modify. This is self levels. Okay, so now we have the indexes into the levels. I think again, let's do the dumb thing, and then we'll refactor. So we know that the nursery right, in this one we need that loop, right? And let's just return none for now. We don't know what or we can do to do, right? We don't know what this needs to be yet. Okay, so we've got the nursery value and we've got the first key from all of the levels. Let's do something similar to this. Okay, so now here, this could return none, right? These might okay, so min by returns an item from this. I don't know that I want to put this expectation here. The problem is this is going to be potentially sum of none, which is fine. Let's see. Yeah, because this is not right. Well, it's saying unused variable. What's wrong there? Yeah, and it's unreachable. The question is, does this okay, this is just returning the index of the smallest one, right? This is not returning what it is. So this is fine. And we should get something, even if it's the first thing. I think the problem here is that these are not... We need to include the nursery in this. I feel like this logic is going to get really complicated really fast if we don't. Because if the... We need to treat the nursery like a level, but it doesn't have the same interface. Because it, you know, it's special, right? Right? It's option. Okay. Let's do something. I'm getting analysis paralysis here. Let's just say if it's none, then we don't care. Like, so we've exhausted that, and we should take whatever it is from the levels, and then we can handle if it's some. So this is the simpler case. If we only care about what's in the levels and not in the nursery. So the nursery is none. Then we can do basically similar to this. Yeah. Okay, this is not right, but we're going to copy it and modify. And then we'll see if there's something that we can do here. Okay. Right, so we have that. Put to do there. And we need to say levels. This is levels. Okay. So this is basically the same because we want to consume the same key from all of them. Here, return. We're gonna have to bail there. And that's not right because we need to formulate the result into something. So this is where we care about right. And this returns vec, so we need to make sure those are cloned. That's a vec. That's a vec. Okay. So here we're going to loop again because okay. Right, so this same kind of structure will work, I think, this little loop. And here there's nothing returned because it's a tombstone. And we'll say level iterator emitted poslin. Okay. It's just something we have to handle. Okay. So now, again, let's do it the dumb way, and then we'll figure out how we can we can do this better. Yeah, and actually I think we might want to just put this, because we honestly don't have to do and let's turn this, let's see if it'll let me turn this into a match. And we'll say none here. And this will be sum. And then we can do we can maybe deal with the different branches of what the nursery value is. You know, let's pull this back out. I think we're going to need it. And if we're going to do this computation on every iteration anyway, we might as well do it up here and instead of having it pasted in multiple places. Okay, so here I want to potentially let's say nursery key nursery value. Okay. This is not great, but we're going to figure it out. Okay, so now what we can do is go let's see, smallest key is going to be keys and indexes, smallest key index .1, right? Yep. Okay. Now what we want to do is go. What I want to see is if if this key okay, if the nursery key is less than the smallest key, Yeah, okay, so we need to handle multiple cases here. And this is getting ugly. I'm really sorry. We will figure it out. We will figure it out. Okay, so if this is sum, and we'll say smallest key, and if, let's see, that's going to be U8, and that's going to be vec U8. Those should be comparable. And okay, so this is not great, but we'll get it. Okay, so if it's greater than this key, the nursery key, then we don't need to advance any of those iterators. This is really, really ugly. Right, we'll do none here. I'm gonna do, I keep saying this, but I'm gonna do a lot of repetition, and then we will factor it out. We'll find out the parts that are common. Okay, so if this, let's do match nursery value. Okay, if it's a plain, let's say value, then we want to return some nursery key value. That's not correct. But if it's deleted, we want to continue. Right, because we know that we're going to, yeah, so what's wrong here? Okay. Clone. And value is, yeah, except I need to do more parens. First of all. Okay. So let's before we go on, what's wrong here? Right, there's another sum here. And this is if it equals nursery key, then we need to consume, right? I'm gonna put to-dos here, and then the last case is if it's smaller. Smaller than nursery. And this is basically what we do up here. We should do this. This is not pretty. So interestingly, if this is none, or if the key is greater than the nursery key, then we basically do the same thing. So I'm going to copy that. We'll need to make sure that we have a base case, right? Okay, I'm going to put to-dos in here. Again, this is not feeling great. We will figure out how to refactor it in a few, hopefully before the end of the stream. Okay. I'm going to turn this into an if-let. That feels a little bit better. Right, so here, if this is smaller than the nursery, this is basically this. Feels bad to copy pasta that. So we'll figure out a way to make that cleaner. Okay, now if they're equal, then we want to do basically this again. But we want to iterate through, and here we don't care about the index. We just want to go through all of them. We don't need to let result there. Okay, I'm going to hide the shell for a minute. The fact that we have to handle the nursery separately is kind of annoying. Okay, so I think how this is broken up is with these guards, I think is not right. And what we need to do is pull out the common stuff. So we know at the end, either once we compared the keys, we know that we're either going to go through all the levels and slurp them out, slurp out the value and so forth. So either we get the result from the nursery, or it's from the levels. So there's that. If we're getting the nursery, we're doing this bit every single time. And there's this bit about that we're looping through and consuming the key. That's in common. You know, we've done this probably like, yeah, see, we're doing it down here too, right? This is not great. The duplication is a place where we could have bugs creep in. And it's just hard to follow, honestly. Okay. So let's start to reformulate this. Okay. So there's I'm going to do something here. I'm going to inline that. That's not great, but that kind of cuts down on an additional assignment that's not really necessary. Maybe it was necessary. I don't know. It just feels like we're assigning and immediately returning some of that thing. Okay, maybe we need to do something like levels. Let's see, level is smaller than nursery, right? Because that's this case. Okay, so this is this. Right? Okay, because what I'm trying to get here is, do we need to go and look at the levels? The only case that we need to go scan the levels for the value is if it's smaller than the nursery key. So if it's none, like if there's yeah, if it's none, then we know we choose the nursery key. So and that's what we do here. Oops. What did I do? I broke something. Oh, no, wait, no, that's fine. Okay, so if it's smaller than nursery, then we do that. If it's not, then what we're going to do at the end here is that. That's the thing in common, right? And then otherwise, we're going to do that. Okay, let's read through this, and then we'll do some more semantic compression again. Okay, so we're determining whether the smallest key from the levels is less than the nursery. If it is, then that's the thing we want to find. So we're doing this, right? And if not, then we're going to consume all the iterators in the levels that are the same. Now we might be doing unnecessary work. There might be an optimization here. Where we could go level is equal to nursery, which is basically this, and we do equal. That like indicates that we should do this loop. Let's inline that again, so it's the same. Now we need to look at I kind of want to see if I could extract this into a function. No, I can extract into a variable. The problem is these are in different branches. Maybe we can do a little function here, a little inline function or closure. It's probably going to get into borrowing issues, but not if we can pass the right things to it. Let's call it scan levels. And we will do let's say start index. Let's not annotate them yet, and we'll say levels. And we'll I want to pull this out, I think. So let's put it in here. We're going to change self.levels to levels. And this is start index. This is start index, and this is levels.len, and this is so forth. The problem is this continue bit. Yeah, that's not going to work as a closure. Do it as a macro, a declarative macro. I don't really like that, because then we lose the typing that we're getting in here. There's something about the structure of this that is kind of bugging me. The repetition. Let's just undo that. We have these two things. We could do... I don't think we need this. This is an optimization. So let's remove that. I'm trying to cut down on noise as well as complexity. Again, this little loop here, appearing so many different places in this file, is bugging me. Let's see if we can extract it into a function. Let's rename that. Consume level keys. Sure. And then we could do that here. So we could do self.consume level keys, and this is going to be 0, right? And this is nursery key. And I think that's borrowed. Okay. And then we can do that here, right? Yep. Okay, so we factored out one thing. Now we have a problem of borrowing. Okay, we've got a mutable borrow here. I think maybe if we clone? No, that doesn't do it. Okay, let's continue refactoring. Maybe there's something else that we can... I'll move that down. Yeah, there's this, it's interesting it happens here and not here. do like that. And we need to do that. Clone and cloned are not the same. Okay. That actually resolves that. That's good. And it's fine to clone that there. That'll solve our issues for a little bit. Okay, we're still on our goal of cutting down the duplication here. The problem is this continue. Because that cannot be extracted. But this does feel like let's do a little analysis here, because I think that what we might be able to do is right, so let me collapse this a little bit. Yeah, okay. So I think that maybe what we should do is pull this out, because we're already doing this here. Right, this is straight duplication. And then what we can do is go if it's not smaller than the nursery, here, let's put this back first. Right, if it is smaller than the nursery, we need to do what we're basically doing down here. If it's not, yeah. So, okay, I'm convincing myself. Bear with me. Okay, so if it's not, then we can remove this from the else. Getting better. Okay, so right, so if the nursery has, basically we're kind of combining this. If the nursery has a value for it in its iterator, and the smallest value from the levels is not smaller than smallest key from the levels is not smaller than the nursery, then we want to return the nursery value, right? Otherwise, we want to consume the one from the levels. This is starting to feel better. There's still some compression I think that we can do here. I'll start with, can we invert this? Instead of not smaller than the nursery, let's do greater than or equal to and unwrap or true. Right, so if it's none, then the nursery key is, you know, what we should do, and then we don't need the not, and then I'm going to inline that. Not prettiest. Yeah, because if it's equal, then we need to consume these. If it's greater, then we'll just loop through them and find that there's nothing to do, which is fine. Okay, that's better. I wish wish you could compress this more such that this is not two nested ifs. We don't match. I mean, we could turn it into a match. And then this can be the guard. And we don't need that, and we don't need that. I don't know if I like that better or not. There's a lot of branching in this code, and I'm kind of worried about it, you know. And we've cut down a lot of the repetition. We extracted that function, which is, you know, and maybe we can do that in our other. Except we don't repeat that, right? We don't repeat this bit. We already factored out that because that was between the tombstones and the key value entries where it was repeated. Let's inline that. We're getting pretty close. Feeling decent about it. It's not ideal. Is a very high complexity function still. What more can we do to simplify this, to compress it? We can inline this. So we don't need it outside of the case of this branch. That's pretty tight. I still not real happy with this. Let's move this down so that the sum is first. We could remove this guard and put it into the match. I don't know that it's strictly necessary. We would do the same thing down here. Honestly, I kind of want to do this. Yeah, anywhere we have a continue. say key was deleted. Try the next one. We can remove that clone. Yep. And the value doesn't need to be cloned here either, because we already cloned it. Cool. I think we need to do, before we finish up today, I want to write a test for this, of course. Well, we have this. Actually, this will be our test. The thing I want to make sure happens is that we always have an exit condition from this loop. Now, I think the compiler is pretty good. It'll be noticing whether we continue forever. But the worst thing to possibly happen is that we continue forever, right? So let's do a little bit of eyeballing it, and then we'll go and we'll do this test. And I think that the main thing that we need to cover in this public API test, which we might not be doing, is putting some deleted keys in there. I think this is a fine thing for, we inserted 30 keys and we can scan them and get them back in order. Right? Okay. All right. So let's eyeball this, make sure we have an exit condition on everything, on every branch here. Okay. So we enter the loop and we do a peek on the nursery iterator and we clone out that value. And if it has anything left in its iterator, and that key, and all the keys in the levels, the smallest key in the levels is greater than or equal to that key, then we want to return the nursery value. So then we consume all the keys that equal the nursery key in the levels. I'm going to rename that function. And then we either return whatever the value was, if the nursery value is an entry, an actual, or it's not a tombstone. If it's a tombstone, then we continue. We go back up to the loop and try the next one. Okay. Now, if the nursery doesn't have a value left in its iterator, so it returned none, or the key of the nursery is greater than the smallest key of the levels, then we dig into the levels to get the smallest entry there. Okay, so now we're down here, and I'm going to put a little note here. Either the nursery was exhausted or the levels had a smaller key. Okay. Okay, and then we've got So we're getting the youngest level, its key. Okay, and here. Oh right, no, this is fine. Okay, so if it has a key and that is either a tombstone or key value, then we want to consume all of the matching keys to this one. And if it's a key value entry, then we return the pair. If it's deleted, we go back and we try the next one. Now this gets interesting in that if the smallest key is nothing, there's nothing left, then we know we've reached the end of the iterator. Now, if this goes back to checking the nursery, so let's say we have a nursery value. If the smallest key index is none, then we want to make sure, I'm sorry, not the smallest key index. If the value of the iterator, the first key in the iterator for that smallest key index in the levels that we computed is none, that means there's no data in any of the levels left. We've consumed it all. Then, and we have a nursery value, then we definitely want to return that nursery value. So let's say we consume either like the levels are completely empty, and there's only data in the nursery, or we consumed all of the data in the levels and there's still entries in the nursery that are like of larger keys. Then we definitely want to be returning this. So I think that I feel like this is good for reaching termination. And note we're doing return sum here. So if inside this match we get the continue, it's not going to return, right? It's just going to go back up to the loop. This is not ideal. This might be a case where we want to break it out. And you remember I did inline that variable. Maybe it makes more sense to have, like, from a logical standpoint, the continue inside the return feels a little bit eh. You know, these are early breaks. All right, I think what we should do is run the test and pray that this test passes. Okay, it failed. So it'll be interesting to see what we get from the result. Okay, on line 119, so we got key dash and we got, ooh, interesting. So I think what I want to do is I need to wrap up for today. I think I want to let's see what is key ASCII table. What is 48? 48 is key 0. So it happened on the first iteration. We didn't get key 0, right? That's interesting. Now, there's another issue here in that test, which we need to address. Let's address it real quick, and then we will we need to make sure that that has a leading 0, because we've got 30 keys, and we don't want to get, we want to get 0, 0, right? We don't want to get 0 and then 1 and then 10. So it's not going to fix this, but let's go ahead and run that. And then we'll wrap up. Next time we will we'll go in here and try to debug our logic a little bit. So okay, so interesting. We expected 0, 0, and we got 0, 1. So I think I think we'll go in and we'll add some issue some prints in here as we're iterating through. I think we have a good idea that the individual levels, it's probably a nursery issue. The other thing is this test is probably operating entirely out of the nursery. So we need to think about, did we do something wrong there? But, you know, incidentally, this is the very first key. We're expecting it should be, that was the issue we already peaked. Let's remove the peak real quick. And let's go fine. At the end we should have that's basically the same thing logically. Let's see if we get the same issue. It may be the peakable bit that was messing things up. No, it still failed. Okay, we will need to do some stuff. Yeah, we've just got the same error. Okay, so let's I'll make a commit. I didn't make one last time. This is session 20, full buggy implementation of scans. And I'll push that to main, and we will address this problem next time. So thank you for sticking around. If you came, if you're watching on YouTube, you know, I'm here Sundays, 1:30 p.m. Central. So please join me next week. Thank you so much, and we'll see you next time.